So today we're going to be talking about a muscle contraction, an overview for it. This is the way I like to think about it. So if you guys have any other tips or anything or questions, please leave them in the comments and let me know what you think of the video. Thank you so much, and let's get into it. So here we have the presynaptic nerve. And as you know, or as you might remember, a sodium depolarization conduction is coming down this way. So this is sodium. And what will end up happening is this will cause a eventual influx of calcium, and the calcium here, calcium has 2+ on it, will cause a release of these vesicles. Vesicles are just storage molecules, basically. So these storage molecules get released into this area right here, and what this area is called, this area right here, is called the neuromuscular junction. And I'm abbreviating it NMJ. The reason it's called the neuromuscular junction is right here, right after this area here, we'll have this muscle right here. Okay, so this area is M for muscle. Now the muscle on top of it will have receptors, and these of course are acetylcholine receptors, because receptors have to bind to whatever molecule gets released. So this is the acetylcholine receptors right here, and this I'll denote it with an A. Just a minute here. These are the acetylcholine molecules. I'm denoting an A in here. So an acetylcholine molecule will bind right here to its receptor, right on top of the muscle cell. This will cause another propagation of signaling. Remember, nerves in our body, nerves and muscles in our body, the way they communicate is via molecules, and molecules binding to receptors is what causes this propagation of signal, or just basically this is how your body transmits signals to one another. So the way we're going from a nerve to a muscle, which is kind of weird, is we're sending a acetylcholine molecule to come bind to the acetylcholine receptor. Once that happens, the muscle then will end up having another potential. Now, the interesting thing about this is once that happens, there's something really cool inside of muscles. And what's really cool is that inside of muscles, they will have this invagination, or this like weird indentation in muscles. And obviously we can't see them because they're microscopic. But these little indentations or invaginations, whatever you want to call them, they are called the T-tubules. And these T-tubules are really cool because the signal actually will propagate. So remember the signal that we just made. Just as a quick review, remember we had a presynaptic nerve, released acetylcholine, bind to its receptor to on top of a muscle cell. Then the signal, there's a new signal once these two bound going down here. Now the signal continues down into the T-tubule because it's running along the muscle. Now the cool thing about this excuse me, is that the T-tubule actually has two brother receptors, brother, sister, whatever you want to call them. I like to just think of them as like brothers. Okay, so these cool receptor guys are called the DHPR and ryanidine receptors. And these interesting receptors, let's draw them right here. So this receptor, this coupled ryanidine and DHP receptor, is coupled right here. Let's try that. This is the ryanidine receptor right here, and this should be the dihydro. I actually don't know what DHPR stands for, so give me just a second. DHPR. DHPR. Okay, so that's these two receptors together. Now, this ones are basically you can think of them like a door. So why do we even care about this weird signal that's coming down to the T-tubule and causing and stimulating these two like so-called brothers? Well, a very interesting structure right here sits with these two receptors, and this interesting little box here is called the sarcoplasmic reticulum. Okay, sarcoplasmic reticulum. Okay, let me just move down a little bit. So the sarcoplasmic reticulum is very interesting in that it has our buddy calcium in it. And this is calcium's home. The sarcoplasmic reticulum is essentially where calcium lives. And it's not going to open its doors until there's a knock. And the knock is essentially the signal that's coming down here. Now, you can think of ryanodine and DHPR receptors as the door. Once the signal gets here, it's the ring or the knock, and the door is going to end up being opened. So when we open the door, what's going to happen is these guys will pull and they'll open the door here. Okay, so calcium now can get out. Remember, this is happening all inside of the muscle cell. Now, calcium can leave the sarcoplasmic reticulum, and it's happy because it can, go out and it's free. But it has a very specific function. Once it leaves the sarcoplasmic reticulum, it can actually go and visit its friend right here. And its friend, let's make it in a different color. Its friend right here is a molecule called troponin, and we'll call it T for troponin. Now, let's talk about troponin for a second before we have these two guys meet. Now, why is troponin so neat or cool? So, troponin actually is bounded by is sitting here and bound to something called tropomyosin. And we'll call this like tropomyosin. These aren't really the denotions of how you should denote them, but, I'm just trying to shorthand them for yourself. Okay, this is troponin, this is tropomyosin. And what tropomyosin does is he's kind of like a let's say a bad guy. And what he's doing is he is binding and stopping actin. Here's like actin molecules. These are actin molecules. I know this is confusing. Just give it 1 second. It'll all make sense in just a second. Here's actin, okay? Now, actin is stopped from going to see its friend, or I've heard it being called like a love story. If you look up YouTube, there's definitely been people who've called it a love story. I can't remember the channel. Comment the channel if you remember that did that. Much credit to them. I'll look it up afterwards. But it was just a love story between actin and myosin. Okay, actin and myosin. So actin and myosin love to interact with each other. And once they interact with each other, we can get what we're all here to talk about, which is the muscle contraction, okay? So we want the muscle contraction. That's what we want. That's the big guy, okay? So what happened here? What was our entire problem? What's going on? This part is getting a little bit confusing. Okay, let's review. Remember, you remember that the nerve conduction came up to here. Ryanodine and DHR was the knock, opened the door, calcium came out, okay? Now, calcium hasn't had time to visit his friend troponin yet. And we were talking about troponin by himself. And we said troponin is bound to tropomyosin, and tropomyosin is the guy that's preventing actin and myosin from having their love story and interacting and causing the muscle contraction, what we want. So, why is our buddy calcium so important? Well, what calcium does is he actually comes here and he will bind to troponin, particularly the troponin C part. Troponin has like 4 components. The troponin C part. And what happens is once troponin is bound, what will happen is there'll be a change of heart in tropomyosin. So tropomyosin will actually let go, and it'll stop covering up the actin and let go of actin and let actin do its thing. Once, maybe we can think of it as being distracted. Maybe we can think once calcium binds to troponin, tropomyosin's distracted. And now, once tropomyosin is distracted, this actin and myosin can interact and cause the muscle contraction. Can cause the muscle contraction to occur. And these two interacting is what is so important for the muscle contraction to occur. So let's give a quick review here. So remember that the postsynaptic neuron, we had sodium come in, calcium rushes in, acetylcholine gets released at the neuromuscular junction. It binds to the acetylcholine receptors on the muscle, and it sends a signal that propagates down the T-tubules, stimulates the ryanodine DHPR receptors to open the doors on the sarcoplasmic reticulum, which released calcium. Calcium comes, binds to troponin, troponin, the troponin C portion, and that stops tropomyosin from stopping the myosin and actin from coming together and causing a muscle contraction. Now that's it for this one. We're going to talk about what happens with the love story between actin and myosin. I seriously forgot who's the one who had originally said that was a love story. It's very popular, and 100% credit to them to doing that. That's not my analogy, but in the next segment, we'll talk real quick about what happens between actin and myosin when they interact, what's going to end up happening, and please subscribe to the channel because there's going to be more medical stuff, fun stuff, medical vlogs and everything, and me just giving you random knowledge that I have. All right, thanks so much.